I like to sort of take the conversation away from the what was food 50 years ago and what is it now concept and say, there was a variation 50 years ago. People that were eating stuff from the farm that was grown well had access to stuff that was much better than what might have been in a grocery store. And that's exactly the same situation now.
Welcome to Doctor's Pharmacy. I'm Dr. Mark Hyman, and this is a place for conversations that matter. And today's conversation is with Dan Kitteridge, who's going to tell us about something that's critical to our health, which is something you might have heard about from me before, and it's nutrient density. How do we measure the quality of our food? How do we look at what is in our food and whether it's providing us with the nutrients we need to be optimally healthy? Now, Dan is a farmer. He's an organic farmer. He's been a farmer for over 30 years. He's founder and executive director of the Bionutrient Food Association, which is a nonprofit that is designed to help increase the quality of food in our food supply. He's one of the leading proponents of what we call nutrient density. And in my first book, the Ultra Prevention book, I wrote about the nutrient to calorie ratio, which is the same idea of nutrient density. He works to demonstrate the connections between soil health, plant health, and human health, which are, by the way, all connected. Out of these efforts was born the Real Food Campaign, which has engineered a prototype of a handheld consumer spectrometer. That's a little machine that tests nutrient density when you go buy your food. So you literally scan your vegetable and you can see, is it nutrient dense or is it not? And via the bionutrient meter, the goal is to empower consumers to choose for nutrient quality and thereby leverage the economic incentives to drive the system change in our food supply. So I'm so excited to have you, Dan. Welcome.
Thank you very much. I'm honored to be on your show.
Now, you're from Massachusetts, too. And when you were 4, your parents purchased an organic farm in Barre, Massachusetts. You grew up on the land. Your adult years, you started to manage the farm. And after you got married at 26, you saw that things weren't so great and you needed to change something and make a living and not just get by. So tell us about your journey into farming and how you got where you are today.
Okay. Well, yeah, like you said, when I was 4 years old, my parents bought a piece of land on a dirt road and built a house and started a farm. And it was a homestead with a root cellar and a wood stove and milk cow and orchard and the whole thing. So I like to say I grew up maybe more Amish than English, as the Amish would call it. Even though, So anyway, had that sort of background, and my parents ran the local organic farming organization here in Massachusetts called the NOFA, Northeast Organic Farming Association, for 35 years. So I was very well sort of ensconced in that community, that movement, as it were, and had not necessarily willingly been working on the farm most of my childhood, and then never after that found any other viable income stream that I felt more inspired by. And so traveled the world and did all kinds of interesting things in my early 20s. But then when I got married and thought that this lifestyle of a homestead was actually pretty optimal for raising a family, I thought I would try to do it myself. And so saved up some money and bought an old rundown wreck of a place and started building it up. And as part of that process, had come to the realization that one of the reasons why I was having a hard time making a living economically as a farmer was similar to many of my peers, was that because the plants were not particularly healthy, as defined by being attacked by insects or diseases. I like to say a flesh-eating fungus, is not a sign of good health in an animal. It's also not a sign of good health in a plant. And, we've sort of inured ourselves to that through agriculture, and just there's strategies to kill the fungus, but we hadn't really been thinking deeply about why were the plants susceptible in the first place. And so at any rate, I'd been brought up with this idea that organic was better. And at the farmer's market, we kind of had our noses a little bit higher in the air because we were organic. And but then I thought, maybe if our plants are basically sickly, weak, maybe, non-toxic is better than toxic, but maybe there's something more than just non-toxic. And so I was the question.
So, your organic vegetables didn't look that great, or they weren't as nutrient dense as you thought they should be?
I'm not saying they were bad. I mean, it's on the continuum, and the term nutrient dense wasn't even something that we were necessarily didn't exist. This is 10, 15 years ago or so, in this frame at least. And so, I basically engaged in a process of self-learning, went to conferences and read books and practiced, and it didn't take too long, still staying within the organic structure, but just changing practices to get a dynamic where my plants were pest and disease resistant and their yields were higher and my cost of production was lower, and I could make what seemed to me a good basic living on 20 hours a week farming. And so um, I basically came to the conclusion that if my parents had ran an organic farming organization for 30 years and I grew up on an organic farm and I was not versed in some of these principles, then perhaps other people weren't also. And so I started giving workshops, and those turned into courses, and that turned into an organization. Um, so yeah, for the past.
So Dan, you're saying it's really interesting. You're saying you were doing organic farming, and yet it wasn't good enough, and there was some breakdown in the process of how you were cultivating the plants and the earth
Yeah.
and soil and the ecosystem on the farm that wasn't optimal. What were the changes you made that actually made it better? And what do you call it?
Try not to actually call it, but I think, I mean, the shift, it was a shift in understanding that plants in nature have evolved with the capacity to flourish, in large part through critical symbiosis with their microbiomes. And when we as farmers or land stewards of any scale are not engaging in a way to support the vitality of the microbiome, then we're pretty much guaranteeing the plants are not going to flourish. And so things like fertilizer, things like tillage, things like and there's any number of things that farmers do, because we have sort of been trained in that it's more of a mechanistic process. You put the seeds into the pot, you buy the potting soil, you buy the pot, you put it in the ground, you put the fertilizer in. It's not understanding that plants have evolved this profound way of living. It's so that's the biggest shift. I mean, I call my course, after 10 years of digestion, Principles of Biological Systems. How did nature evolve this thing to work? And foundationally, we're not trying to control things. We're trying to identify where nature is struggling, identify the limiting factor, address those limiting factors, and get out of the way. So
it's really working with nature rather than against it, right? And
yeah, foundation.
And I remember
nature's in charge, and that plants have evolved a way to work with nature. And if we support them, then they can, everybody's happy. But if we don't, then pests and disease and everything else. Yeah.
So you're saying organic agriculture has limitations because it may use practices that actually limit the benefits around building a healthy microbiome in the soil, like tillage, for example. So you can have a big organic farm that's tilled like crazy and destroys the soil and the microbiome and the carbon, and ends up not actually creating the benefits that you like, right?
And it exists. I mean, I think we have this sort of way of naming things and bifurcating things in this sort of Western sort of mental construct. Like, there's conventional over there, there's biodynamic, there's permaculture, there's organic, there's agroecology, there's whatever.
Regenerative, right?
Regenerative, of course, the new ism, right? So ideally, they are all sort of lenses that we can use to access deeper insight into how does life work. And there may be some organic farmers who are doing an exceptional job, and there's probably some who are really not, and some conventional growers who are doing a really, really good job, and some who are not. And so it's not about the label per se, it's about the result. And that's really what we've been trying to focus on with our organization, is say, let's integrate the insights from all these different streams of thought and let the results be the metric, not a label. And so our thought is that the result is the nutritional value of the food. It should correlate with greater health,
right,
with better soil health, et cetera. But as far as like a metric, let's let the nutritional value of the food be the metric, and understand that it's not a binary. You either are nutrient dense or are not, but it's a continuum. There's like absolute junk, a bunch of stuff, a little bit better, some few that are pretty good, and there's like the outliers that are exceptional. So anyway, so yeah, I mean, the work started in educating growers, and that sort of has spread fairly much by word of mouth over the past 10 years around the country and around the world. And we always had this idea that if it was true that healthier plants produced crops that were more nutritious, then perhaps people would like to have access to them. And so the question is, how do we actually facilitate a process where people can make those educated choices?
Yeah, it's amazing. I want to back up a little bit. You said it was really important, because the focus of agriculture over the last 50, 60, 70 years has been the production of abundant calories,
Yeah.
which usually means a lot of extra starchy calories.
Hmm.
So the corn, the wheat, all the foods are more abundant in how they're bred to produce these extra calories, which are not necessarily nutrients.
Well, and the beef is produced in great quantities too, but the calories, the nutrients are not balanced, right? Regardless of whether it's a grain or it's a animal product or a vegetable. Um, yeah, we have been working to create volume, but not necessarily quality.
Yeah, and so plants are bred for stability of transport, for shelf stability, for you know more uniform size and color, for content of calories and starch, but not for nutrient density,
Not for flavor.
which is
Not for
which
flavor.
is and not for
Yeah.
flavor. And this is such an important point. We've had people on the show before, Dr. Fred Provenza, who talked about the connection between flavor
Yeah.
and nutrient density, and we've had Dan Barber on, who's
Yeah.
created Row 7 Seeds, which is about breeding for flavor, which he cares about as a chef. As a doctor, I care about the nutrient density of the food, which goes along with the flavor. So the more flavorful food is, with just on its own in its natural state, the more nutrient dense it tends to be, which is
Yeah.
pretty interesting. And I think that's the good news. The more you want to, it's going to be more nutrient dense, it's going to taste bad. No, it's the opposite of what actually
Yeah.
happens. And years ago, I took a course called Biological Agriculture, 1979. That dates me, but I took a course in
With
Vermont
whom?
at the Institute for Social Ecology, and it
Okay.
was
Yeah.
an incredible summer experience. We took all sorts of classes, but one of them was on biological agriculture, and we learned about how to work with nature rather than against it, and all sorts of things. Like how to build, the soil, and how to compost, and how to do intercropping and pest control with natural plants like marigolds. With certain plants, so like marigolds, how you actually do cover crops, how you do crop rotations, all the whole idea of how do we actually build soil. And Sir Albert Howard had written
Yeah.
a book that I read back then called The Soil and Health, which seems like an odd,
Hmm.
juxtaposition, but it turns out, and he said, the whole problem of health in soil, plant, animal, and human is one great subject. And I think this is sort of what you speak
Yeah.
to a lot. It's just these are not disconnected things, and they're and if we want to have healthy humans, we want to have healthy plants, we want to have healthy animals, we have to have healthy soil, and that's really where it all starts. And you talk a lot about it. How did you first kind of understand that all these things were connected? Not even human health, but even planetary health, right? So you've got soil health, planetary health, and human health.
And one might argue cultural health and spiritual health. Yeah, there's all kinds of things that I think are
Hmm.
probably fairly intrinsically related to this dynamic. I personally, I had always asked the question why from a very young age, and never found sufficiently gratifying answers. And so I spent a lot of my late teens and 20s traveling the world and seeing other cultures and getting deeper insights. So yeah, I mean, I think it does end up being one of those things that people come to, that things are connected. Um, and um, it's one thing to sort of be angry and to judge and say that person's dumb or that group is wrong, but really I think what it comes down to is how do you build solutions? What are the leverage points? How can we strategically take what we know and build the solutions we're looking for? So yeah, I mean, my personal background was in the organic farming movement, and so it just ended up for me being a potent insight that if we can increase the nutritional value of food, we can increase the overall vitality of the human population. We can presume to be decreasing chronic illness and all that kind of stuff, but we're also having this really profound impact on the environment.
Yeah,
Balancing the climate, building soil, revitalizing ecosystems. When you have healthy plants, they are literally indigestible to bacteria and fungi, so you don't need insecticides, right? You don't need
that's so true.
fungicides. Um, fertilizers. Fertilizers are like kill the soil microbiome. So when you have healthy, healthy plants don't need fertilizer, and so you don't need to add fertilizers. So we can,
Hmm.
think about the externalized, factors that agriculture is, you know, responsible for right now, and think about how we can systemically if we could systemically, ameliorate them, I think that would be quite
Yeah.
exciting. And so our thought is basically if we give people the ability to choose which food they purchase and feed themselves and their family based on its inherent nutritional value, they're going to, from their own selfish, perspective, choose things that are good for them and taste better. Um, and that will drive a way of working with land, which can be most potent in, you know, healing the environment. So,
So let's talk about
yeah,
how do we get nutrient dense food, because most people don't understand what makes a food nutrient dense. And you talk a lot about how the
yeah,
microbiome of the soil is so critical to actually making plants and the foods we eat nutrient dense. And it's something most people don't think about. How does the soil have to do with nutrient density? And the fact is that we are
yeah,
now in America in a crisis of malnutrition. 90% of Americans are
yeah,
deficient in one or more nutrients at the minimum level to prevent deficiency disease. And that's just the minimum. Like, in other words, how much vitamin C do you need to not get scurvy? Not much, 10 milligrams, 60 milligrams. How much vitamin D do you not need to get rickets? Like 30 units. So we're in a situation where we have created a very nutrient depleted diet. Forget the fact that we're also just eating a lot of processed food. Even the good food that we're eating, you're saying, isn't
yeah,
as good as it could be or would be or should be based on understanding of how
yeah.
to restore these ecosystems. So talk about the sort of microbiome, which is the sort of trillions of bacteria, fungi, viruses within our body, and how that relates to the food we eat and how the food is even grown. Because how the food grown doesn't necessarily seem to link back to what happens in our own microbiome and why that's so important. By the way, for people listening who've heard what a microbiome is, it's essentially all the critters that live inside you that determine almost everything about your health. There's about 10 times as many bacterial cells, about 100 times bacterial DNA, and it's regulating your biology every minute. And it's linked to so many different diseases, such as heart disease, cancer, diabetes, autoimmune disease, obesity, Alzheimer's, autism, you name it, depression, all connected to your microbiome. So if what we're eating is affecting our microbiome in an adverse way, we should know about it. And if we're not eating the foods that help it thrive, we should know about it and how to fix it. So I'd love you to talk about that, Dan. Go in a little detail about how that all works.
Yeah. Well, I was talking about the plant's microbiome, but it's intrinsically related. So, how does well, how about we can start with what is nutrient density? It's one of those terms that gets thrown around a lot. I mean, more and more these days, it seems like, a la regenerative. People use the term regenerative, but there is not actually a clear delineated definition of what the term means. So, I would suggest that we don't actually have a definition of nutrient density. We have a concept at this point, and that's part of what our organization is working to do is to develop a definition. But broadly, what we're talking about with nutrient density is this carrot versus that carrot. What is in this carrot and what is in that carrot, and what's the variation. And
Mm-hmm.
set up a lab, and we've been doing a bunch of sampling over the past few years, and we've been finding variations that are absolutely stupendously large, within
Wow.
this carrot to that carrot, this spinach to that spinach, this wheat to that wheat, etc. So
Based on where it's grown or how it's grown?
exactly. So we can get into all that in a second, but let me answer your question. I just wanted to make the point that nutrient density conceptually says there's this variation between, within, what we're saying is within a crop type, within wheat, within rice, within apples, within pears. And so, what causes that variation is, really the environmental conditions that plant grew in. So part of it is the genetics, the variety. If you have a variety that's been selected to grow big but not, have flavor, then it's likely to not be as good at picking up nutrients. And a lot of the heirloom open pollinated varieties were selected over time for flavor, among other things, which, as we said earlier, correlates to nutritional value, nutrient density. But foundationally, the compounds that we call flavor and aroma, in science are called plant secondary metabolites, antioxidants and polyphenols and terpenoids and alkaloids, and there's all kinds of fancy names for them. But they're very complex compounds. Maybe thousands or tens of thousands of elements in each one, and they are signals of overall, coherence in the plant. Among other things, they are what makes the plant indigestible to an insect or a disease. I like to use the example of a cow. If we were to walk into a room and see a bale of hay, you might consider sitting on it. If a cow walked in, she would consider eating it. We know it's not food for us because our digestive system is not sophisticated enough to break down the complex cellulose, but a cow's is. So in that same way,
Hmm.
a corn earworm or a, Rhizoctonia doesn't have the digestive system functionality to break down these compounds that we call flavor and aroma. And so, there's this constant, people call it an arms race or an evolutionary battle, but I think we can use maybe a more peaceful term. Um, you know, when the plant is functioning at high levels, part of what it has in it are these flavor compounds, which are the very things that make it indigestible to insects. And so, we have this, I would call it an instinct, a natural inherent ability to tell. So when a 2-year-old child takes a bite of a carrot and spits it out because it doesn't taste good, it's their animal instinct saying it's not good for me. I have seen many, many examples of 2-year-olds that will fight over carrots, rip them out of their siblings' hands because they
Hmm.
want them,
Yep.
because they're animals, because they know better, because they actually taste
Yeah.
good. So, um, but what is it that allows that plant to build those compounds? In the environment, we have this broad suite of
Mm.
elements and things in the soil, but plants are not evolved to be able to digest their food. I like to say, in the same way that we animals can't digest our food, it's the people inside of us that digest our food for us, our microbiome. It's exactly the same for the plant, and so the plant makes sugar through photosynthesis with its green leaves, and then injects that into the soil with different amino acids attached to it to feed specific different families of microbes that have the capacity to solubilize phosphorus or potassium or copper or zinc. And so there's this profound symbiotic relationship where the plant is feeding the microbes are going out and digesting the soil, digesting the atmosphere, feeding it back to the plant. And it's only in that system that the plant's able to access the full suite of what it needs to achieve its biochemical complexity.
Hey, everybody, it's Dr. Hyman. Thanks for tuning into the Doctor's Pharmacy. I hope you're loving this podcast. It's one of my favorite things to do, and introducing you to all the experts that I know and I love and that I've learned so much from. And I want to tell you about something else I'm doing, which is called Mark's Picks. It's my weekly newsletter, and in it, I share my favorite stuff, from foods to supplements to gadgets to tools to enhance your health. It's all the cool stuff that I use and that my team uses to optimize and enhance our health. And I'd love you to sign up for the weekly newsletter. I'll only send it to you once a week on Fridays. Nothing else, I promise. And all you have to do is go to drhyman.com/picks to sign up. That's drhyman.com/picks, P-I-C-K-S, and sign up for the newsletter. And I'll share with you my favorite stuff that I use to enhance my health and get healthier and better and live younger, longer. Now back to this week's episode.
So we're seeing like the really drop in nutrient levels in a lot of common foods that we
Yeah.
eat. And what you're saying is not necessarily the lack of nutrients in the soil,
Correct.
but the lack of the live microbiome of the soil that is needed to extract the nutrients that feed the plants.
In some cases,
And
there are some deficiencies in the soil of minerals, but in most cases, most things are there. And
so that's a problem. So we don't really understand the fact that it's really the fact that we've been killing the soil through the
yeah,
application of nitrogen fertilizers and various things like
insecticides,
glyphosate, which is a
tillage.
soil microbiome killer,
Yeah.
and by tillage, which damages the soil, that we're actually destroying the very nutrition that we need for our own health.
It's entirely perverse, and we will go extinct if we keep it up. So we have an opportunity, I think, to turn it around. What percentage of the Earth's landmass has been desertified through the practice of agriculture through the last 10,000 years? Something like 40%.
It's a lot.
40%.
40%. Yeah, it's a lot.
We have created deserts through killing soil and turning it into dirt and turning it into dust. We can create fecundity, vitality and amazing biodiversity in those, currently desertified areas if we do choose to work in harmony with life. But it's incumbent on us to make those choices. And so our thought is, strategically, most people are bothered with their own personal day-to-day lives much more than they are with, the greater dynamics of the world. And so, survival is it's real. So our thought is, if we can figure out some way to align the interests where your survival is correlated with the regeneration of the earth, then we actually have a reasonable chance of turning things around in short order. And so that's where it comes down to the nutrient density being a lever, is if we can help people say, choose the food that's going to make, reverse your chronic illness, keep your skin looking, young and supple, keep your libido up, whatever it is that you care about, right? For your physiological form, to a large degree, has to do with whether what you're building your body out of is any good. And most of what we're building our bodies out of is relatively quite poor. And so
so it seems like you're a doctor of the ecosystem, of a farm ecosystem, right? And I'm a doctor of the human ecosystem, but they're really connected. And most people don't understand how important the farm is to their own health. So can you talk about that connection?
Just because the label says organic or whatever on it doesn't mean that the ecosystem is functioning well where that was produced. And, your tongue will tell you, but your body will tell you also. It's life. Life is the dominant reality, I would suggest. And the more we're in tune with it and aligned with it, the more we're likely to flourish. And we can't treat life like it's a factory, like it's a reductionist, mechanistic system. I mean, we can, but then we kill it, and we're part of it. So, yeah, I don't know. I think we've covered that point.
It's a huge issue. So, if you say this sounds good, so people go, I want to buy nutrient dense food from the farms that practice biological agriculture, regenerative agriculture, whatever you want to call it.
Yeah.
What are the challenges to doing that today?
Well, as I said initially, the first thing is we don't have a definition. So, people can make claims and say my stuff is nutrient dense, but then whatever, that'll be a fad for a couple of years. A bunch of people will use the label, and then people will realize it's just another fad, and we'll move on to the next fad. So, our thought was, there's a couple of key pieces here in the strategy. One is, give people the ability to actually test for themselves and not have to trust a label or marketing. You're not allowed to take a bite of an apple at the grocery store or at the farmer's farm stand. But we can read what stars are made up of, light years away, with this thing called spectroscopy, which basically is every element or compound in chemistry has a vibration in physics. Zinc vibrates at a certain frequency and vitamin C vibrates at a certain frequency. And so that vibration is light. So if you can take a picture of Alpha Centauri and see what it's made up of, like we can see what percentage it is hydrogen, helium, et cetera. Why can't we take a picture of a carrot and see what it's made up of? So that's what we did. I've got our first generation little meter here. It's, nothing too fancy. It's 3D printed. It's got a little chipset inside, and it's got some, light, flashings of light and readings of light right here. It's open source. It's simple. It's like an Apple II. It's not an iPhone. It's not really slick and fancy, but functionally, we've got a handheld, open source, consumer price point spectrometer that you can use to flash a light at food and get readings off of, and meaningful readings. So one thing is, like, can we give people the ability to tell for themselves and not have to trust some certification system or labeling system, et cetera? The second thing is, can we define the variation? Because when we give you a reading that says this carrot's in the 80th percentile or that one's in the 20th percentile, we want to have actually characterized the full variation within carrots. And then the third leg of the stool is correlating environmental conditions and management practices to nutritional variation. So, the last thing we want is for farmers to be told by their buyer, we don't want your stuff. We want, the fact that this is happening to cause the farmers to start changing their practices so that the buyers do keep purchasing it. And those who are focusing on volume, let their stuff not be bought. If there's going to be 30% food waste or 40% food waste, let the food that's wasted be the stuff that's of least nutritional value, and that, let money drive, a shift. Money drives anyways.
Most farmers don't know the nutrient density of their food, right?
We don't have a definition for it. Nobody knows. We don't even know what nutrient density is.
And the question is, what has been the drop in nutrient density in our food? Is there data on our fruits and vegetables or other foods we're eating, grains and beans, and their nutritional density and content 50 or 100 years ago compared to now? Do you have any sense of the drop that's happened?
Yes. The USDA has done this, the British version of the USDA, the Japanese version, the German version, depending on which nutrient they're looking at and which crop they're looking at. it can be tens of percent, hundreds of percent decrease. But the thing is, how many actual nutrients matter? Is it just protein and calcium, or is it, B12 and polyphenols? And so what was documented 50 years ago or 100 years ago, maybe even they hadn't even identified these compounds yet, much less had
Right.
assessments for them. So I like to sort of take the conversation away from the what was food 50 years ago and what is it now concept, and say, there was a variation 50 years ago. People that were eating stuff from the farm that was grown well had access to stuff that was much better than what might have been in a grocery store. And that's exactly the same situation now. So, like, there was no average carrot in 1950. There is no average carrot now. Every carrot stands on a continuum. The average on the continuum may be lower now than it was, but they're still exceptional and pretty good. And so let's think about, like, finding, defining, sourcing, incentivizing people to grow better. We found variations right now in the past 3 years. We've studied 21 crops now, a bunch of fruits and vegetables and a couple of grains, some roots and leaves. And, when we were looking at things like calcium and potassium and zinc and iron, it was between 300 and 1800% was the variation. So,
Wow.
like, this leaf of spinach will have 3 times as much copper as that leaf of spinach, which would be 300%, or it would have 18 times as much iron as that leaf of spinach. And those are elements, right? And then we looked at antioxidants and polyphenols, which are supposed to be health-giving compounds, and we found the variation was more like 75,000 to 200,000%. Like, literally,
Okay, wait.
this
Stop
leaf of
there.
spinach has as many.
Well, it turns out it's not different. It turns out that there's 25,000 different phytochemicals in the plant kingdom, and they are probably the more important compounds than the actual vitamins and minerals. And yet we haven't
Right.
really been measuring them. What you're saying is there's a difference of 75,000 to 200,000%.
Variation, 75 to 1 to 200 to 1 is what that means. So literally,
That's
I think the biggest one we
unbelievable.
found was antioxidants in spinach. It was 364.5 to 1. So literally, like, you eat this leaf of spinach on January 1st, and then you
Okay,
eat
so it's not
one of those leaves of
200,000%.
every
That's a crazy number. But yeah, that's huge. That's a 75
which is
fold to
200 to 1.
200 fold different. Yeah, that's incredible.
200,000% is 200 to 1. It is 200,000%.
Oh,
Yeah, it's 200 to 1 or 150 to 1, depending on which element, which compound,
yeah,
and which
you're
crop.
right. You're right.
Because we've studied,
That's insane to think about. That's insane to think about. So the
literally,
food quality is that different.
that's the fact.
And
It's
so
not 5 or 10%. The very
wow, that's staggering. And so yeah, we're missing even if we're eating. So I'm getting all my vitamins and minerals and my nutrients from the food I'm eating. That may not be true because I'm just eating whole foods. It may not be true, and it's still why people are deficient because it's how it was grown and where it was grown and what soil was grown in and how the soil was taken care of, what the microbiome of the soil was, and all those conditions that determine the
Yep.
quality of the nutrients in the plant is so critical. And what's so exciting to me is that you've actually
Yeah.
sort of gone ahead with the Real Food campaign and created an educational model and also a diagnostic model for food. It's almost like a tricorder for your vegetables, right? It's like Dr. Spock beam it over the body and see what's going on. So how does this work? Tell us about the technology and what we find and what you're finding with these spectrometers. And are they available and people can use them? Or
Yeah. So I think I said it sort of broadly before, but the principle is called, the science is called spectroscopy, and it's a, many decades old science, and it's what astronomers use, among many other types of scientists, to identify things. And the basic principle, we were taught in school that, you go to chemistry class when you're in 10th grade and you go to physics class when you're in 11th grade or whatever it is. But actually, everything, every atom, every compound is vibrating. So copper is a vibration, zinc is a vibration, vitamin C is a vibration from a physics perspective. From a chemistry perspective, it's a certain number of protons and neutrons and electrons. But either way, you can effectively see what something consists of by taking a picture of the light that vibrates, that comes off of it. And so that's what we're doing, is we're literally flashing a light at the carrot and taking a reading of the light that bounces back. And, based on what's in there, some things get, sort of don't bounce back and some things bounce back really strongly. And you can effectively measure what something is based on that signature. And there's all different kinds of spectroscopy. There's acoustic, there's, UV, there's visible, there's, infrared, there's, there's all kinds of different ways of doing this. And so, what we've got is a pretty simple one. We just literally it's 10 LEDs flashing a light at the carrot and then taking a picture of the light that bounces back. And it's that simple. Like I said, this is an Apple II. It's like the first personal computer. Like you had to be able to code to do anything with it, right? Like it's rudimentary. It's not market ready. It's not mass producible like Slick. So we released the first version of this, I think in 2018, 2019, we started shipping. And when you flashlighted the carrot, what it gave back to you on your smartphone screen was like a little, just the peaks and valleys on a graph. And so what we're releasing in June 1st is an update to it, which will now give you a red, yellow, green. So bottom 25%, middle 50%, top 25%. So that graph, which is nice but doesn't mean anything to you, is now we've gotten enough data and calibrations and algorithms and things to convert it into, this is in the bottom 25% of carrots or the bottom 25% of cucumbers. This is in the middle 50%. That's the middle and top 25%. So yeah, we're making progress. And part of what we're doing is we're pretty dogmatic about the fact that we think this all belongs in the commons. We really don't want it to be controlled by a company or anything like that. So, we're running 4 labs, across North America and Europe. We're, doing all kinds of, software build out and all kinds of other stuff. So
could it be an app that just goes on your iPhone and you take a picture with your iPhone?
Well, when I'm saying take a picture, but you have to be able to take a picture in the right frequency range. And so if the iPhone did build the right sensor, if Apple built the right sensor onto an iPhone, yes, it could be an app. And that is where we hope it will get.
Yeah.
But there has to be a market reason for Apple to put that sensor into their phone. So we start off with these, third generation instruments.
So can people get access to them now, or is it just sort of in beta?
Yeah, well, you can, if you go to our website, you can order one. They're $377 and we'll be shipping in June with the update that gives you the red, yellow, green on.
And what's the website?
Bionutrient.org.
Bionutrient.org. That's amazing. I think a lot of people are going to be interested in looking at what they're eating and seeing, gee, is this carrot or is this broccoli or is this, iceberg lettuce the same as the arugula? It'd be fascinating to see. And it doesn't give you an absolute number, but it gives you a range of red,
yellow, green. Right now, that's
yellow and green. Right?
It's a process, and we are really trying not to make claims that we can't back up. And so, if you read the website, there's like all kinds of caveats and like this is what it is, but this is what it's not. And but it's a process, and we think that the broader food movement and from all the way from chefs and nutritionists to agronomists and growers, we think this is something that we could all come together around. We're not anti-GMO, we're not anti this or anti that. We're pro quality nutrition, and let's learn from each other what the best practices are and the techniques, and let those who are doing a good job be acknowledged for it and supported for it.
So tremendous. Yeah. The book I wrote recently called The Pegan Diet really had as its primary focus the idea that food is medicine, and that quality matters above all else, because the nutrient density and quality of the food determines the quality of your health.
Yeah.
And it's something that if we sort of connect the dots on it, well, wait a minute, we're not just eating for energy or fuel or calories. We're actually eating to regulate our biology with the right nutrients, including all these phytochemicals.
Yeah.
And it's kind of cool to think that there's a way to keep integrity in the system by, at the point of purchase, being able to look at your food, check it out, and see whether or not it is all cracked up to be.
You can market all day long, but if people actually have these things, they can go and check, and they can, and that's the idea. Not that everybody will, but that people can. And our thought is then we can work with the supply chain, the retailers, the wholesalers, whoever else, and help them get these instruments, and so they can make claims and market it. Not everybody else has to have a meter, but if we have a standard that anybody can engage an instrumentation set, and it's all open source, it's in the commons, it's not black boxed basically, And that's the problem.
And you think that'll drive changes in the food supply chain, because when consumers have the power to understand the quality of food or lack of quality, they're going to drive demand for food grown in a different way, processed in a different way, distributed in a different way, right?
That's the thesis or the hypothesis. If you've got, you can choose your Bunny Love or your Cal Organic or your Bolthouse Farm carrots at the grocery store, and one's a 20 and one's a 40 and one's an 80. You're going to choose a 20? I don't know.
That's
I don't
incredible.
think so. I think the one that's 20 will stay in.
Your product might scare a lot of people in the food industry, I think. Because they don't want you to know.
Give them an opportunity to be on the cutting edge. Anybody who wants to get on the cutting edge of this can. And when the infrastructure is in place, the data is collected, and the instruments are out there, people are going to be able to see if Stonyfield is better than Organic Valley or whatever.
Yeah.
And so there's an opportunity here for people that want to walk the talk, that have their climate claims and everything else, to get ahead of the curve, get involved in data collection, engage the process. I mean, there's all this talk about regenerative and soil carbon and climate, and all these big companies are making these pledges. Like, the best way to build soil carbon is with healthy plants, full stop. Yeah. So we'll be able to support those companies in being able to say, this is a carbon negative milk. Like, literally the production of this milk caused carbon to go into the soil. And that's a claim they want to make. Awesome.
It's incredible.
But also, they'll be able to say if this milk is 1-to-1 omega-3 to omega-6, or if it's 4-to-1, right? I mean, that's the nutritional side of it. Is when cows eat grain, their milk is not good for you. And when cows eat grass, it is. So, it's directly connected.
Yeah, and so you're not just going to be able to see the phytochemicals or the antioxidant levels or the vitamins and minerals, but you're looking at also essential fatty acids and other nutrient biomarkers, is what you're saying.
That's the idea. Yeah.
Well, that's incredible.
That's exactly
an incredible advance.
Yeah.
Well, this whole idea of nutrient optimization and the bionutrient sensor essentially is putting integrity back in the system. And I love that you're putting integrity back in the system. So there's transparency all the way from the field to the fork to our bodies. And that is really the key to holding our entire system accountable. Because I think if people start to realize that we're eating food, but it's not actually really what we should be eating to drive our health, I think it's going to drive the marketplace. So I wish you luck, Dan. This is such a great idea. I think keeping accountable for nutrition density and nutritional quality is so key. People should check out Dan's work, and you can go to bionutrient.org to learn more about the bionutrient sensor, and to realfoodcampaign.org to learn more about his nonprofit that helps educate people about the importance of nutrient density and real food and quality. And I think this is really what I've been all about and what functional medicine is all about for years, which is identifying the fact that food is not just calories, but it's information, it's instructions, and it has to do with the quality of the nutrients and the phytochemicals and everything else in the food. So, Jens, thank you so much for being on the Doctor's Farmacy. Really, I love this conversation. I think we're going to open up a lot of eyes about what we are doing, what we're not doing, and even the idea that organic is not all the same. That we have to think differently about where we get our food from a quality perspective, and trace it back from the soil all the way to our bodies is pretty key. So thank you so much for being on the podcast. And if you all been listening, you love the podcast, please share with your friends and family on social media. Leave a comment. We'd love to hear from you. Have you checked out the nutrient density of your food? Subscribe wherever you get your podcasts. And we'll see you next week on the Doctor's Farmacy. Hey, it's Dr. Hyman. If you enjoyed this video, you're going to want to check out this next video coming up.
Protein is the black sheep of the macronutrient family.
Yeah.
That is
so
all
neglected,
we need to
right?
know, right?
Everybody's talking about carbs and fat. Who's talking about protein?
Protein. We've been talking about it for years. It is absolutely the black sheep. It is very emotional for people because it has a face.